Before recording the infrared spectrum of a sample, you often need to prepare it. And how you prepare it will depend on the piece of equipment you are using. So the sample can be a solid, a liquid, or a gas. For example, a liquid sample can be put in between two discs, typically potassium bromide or sodium chloride, which are transparent to infrared radiation, they do not absorb, and then mounted in the spectrometer. And here you've got an example, for example, of two salt plates, sodium chloride or potassium bromide typically, mounted in a sample holder inside an infrared spectrometer. Sometimes for solid samples, they can be prepared in the form of a pellet. So they are mixed with potassium bromide and pressed tightly until a transparent disc is formed. Again, potassium bromide is transparent to infrared radiation. It will not absorb. So the only spectrum observed will be from your sample. And finally, a piece of equipment that, which is the one that we have at Canterbury Christchurch University, is doing ATR-IR, attenuated reflectance infrared spectroscopy. In the sample holder, this is a great technique because it does not require any preparation of the samples. The sample, solid or a liquid, gases need to be held in a sample holder, but the solids and liquids can just put directly into the sample holder with no preparation. Older generation infrared spectrometers were called dispersive infrared spectrometers, and they were quite slow to use. It could take 10, 15, 20 minutes to run an infrared spectrum. The light source would go through a grating, a separation device, which would resolve the infrared radiation into different frequencies. And then there will be a slit that will allow individually each infrared frequency to go through the sample, and that will be detected. So the whole setup was meant the fact that they had to go frequency one at a time meant that the process was quite time consuming, and it could take quite a long time to take an infrared spectrum, as opposed to modern equipment that can take just a few seconds or maybe half a minute to get a very good infrared spectrum if the sample is concentrated enough. Modern infrared spectrometers using something called Fourier transform, and you will often see the technique referred as FTIR, and that refers that the equipment we use nowadays uses Fourier transform to produce the spectrum. It is beyond the scope of this module to discuss in depth how an Fourier transform infrared spectrometer works. But in general, you can get the idea that the light source is split in the equipment in two different bins, and then those two bins, one goes through a fixed mirror and the other one through a movable mirror, recombine again when they go to the sample chamber, and there will be an interference pattern between these two bins, and then the spectrum produced, what it's produced is an interferogram of how those two beams have interacted with the sample, and with a Fourier transform that can be transformed into an infrared spectrum, which is what we analyze.